Sometimes we want to try to determine the value of a limit by looking at a graph of the function. Here's the graph of the function x divided by absolute value of x. Notice that you cannot plug a 0 into this function, but we can still try to find the limit as x approaches 0, if that exists. Notice that in this case, if we plug in values of x that are close to 0 on the right, the corresponding y values we get are all equal to 1. Based on that, we can conclude that the limit as x approaches 0 from the right for this function is 1. On the other hand, if we plug in values that are close to 0 for x, but less than 0, the y values we get out of this function are all equal to -1. We see that from this graph. And because they're all equal to -1, that means they're staying close to -1. And so the limit as x approaches 0 from the left is -1. Now notice that these two quantities are not the same. If they were the same, we would say that the overall limit is 1. But because they're not the same, we have to say that the overall limit does not exist. And that's often abbreviated DNE. Here's another example. Look at this function, x squared minus 3x plus 2, all divided by x minus 1. In the graph here, it looks sort of like a straight line except for a hole. Notice that you cannot plug a 1 into this function because that would make the denominator 0, and you're not allowed to divide by 0, which means this function is not defined there. That's indicated on this graph by what looks like an open circle. You can plug in any value except a 1. Well, that means we can plug in numbers that are close to 1 and try to evaluate the limit. If we plug in x values that are close to 1 but a little bit larger than 1, we're going to get y values on the graph that are close to -1. Similarly, if we plug in x values that are close to 1 but slightly less than that, we're going to end up with y values that are close to -1, which is the same thing. Now, because the limit from the left and the limit from the right are equal, we're able to say that the overall limit exists. And we just write the limit as x approaches 1 without a superscript plus sign or minus sign. So even though the function's not defined at that point, we can still evaluate the limit at that point, as long as we can evaluate the function by plugging in numbers nearby the point x equals 1.